Hello there. Today is your lucky day. We are doing two outcomes at once. So, killing two birds with one stone here. P7.3 and P7.4. They're really similar, so I've put them in the same video for you. Demonstrate an understanding of 1- and 2-step linear equations. So it's something like 3x plus 1 equals y or whatever. That kind of an equation with variables in it. And it gives us the form, how many x's, and it could get divided also, and then it has this chunk added to it, and then it has the answer. We're using whole numbers, not decimals, not fractions, except if it's getting divided, obviously it's getting divided by a whole number. And we can model the solution with objects or by drawing a picture or, I don't know, interpretive dance or something. I don't know what they mean there. And symbolically, so using math symbols like I just did right there. Alrighty, moving down. Let's have a look at our indicators. This is just P7.3 right now, and then I've got another slide for P7.4, but I guarantee you it is all the same stuff. So. Okay, modeling preservation of equality. So keeping that scale, nice circle, keeping your scale balanced. Everything on this side of the equal sign has to equal everything on this side of the equal sign. And when they're balanced, everybody's happy. Using the 4 operations, plus, minus, multiply, divide. And again, concrete, picture, orally, or record it with math. So then, having some sort of strategies for carrying out all these operations. Oh, and you know there's probably going to be some BEDMAS in there, right? Anytime you are doing equations, there's going to be BEDMAS. And preserving the equality, keeping the scale balanced. Solving an equation, which means coming up with an answer at the end that x is whatever, 7 or something. Identify and provide an example of a constant. What is a constant? What is a numerical coefficient? And what is a variable? So you should know what a variable is. That's the x, the y, the z, whatever letter of the alphabet we decide to use that day. And then these two words, expression and equation. So these are all words you can put into your word book. Expression is something like this. Okay, it's just a term. There's a certain amount of x's and we're going to add 1. But an equation is a little bit different because an equation, my circles are not improving, an equation actually has an equal sign in it. So this would be considered an equation, whereas the other one is just an expression. It doesn't have an equal sign. This next one, representing a problem with linear equations, solve the equation and record it. Draw a representation, so some sort of picture to show that you know what you're doing. Verify the solution, so maybe they've given you an equation and you have to decide if they've done it correctly or not. Explain what the solution actually means, and that's why we've combined these two outcomes, is because eventually you're going to graph it on a coordinate plane where you do your x values and then you plot your y value, and you might come up with a location right there, and then you might have another one down there, and that, ladies and gentlemen, can make a line. So that's where we're going with all of this stuff, is using equations like the one that I have at the top to create stuff on a coordinate plane. Okay, so then representing problems, solving problems. Let's go on to the next guy. Here is your P7.4, and it's the same sort of thing, recognizing that similar form of equations and recording it symbolically. So let's have a look here. Represent a problem with linear equation in the form where a and b are integers. So we could have positives or negatives. Solving the equation using concrete models. Verify the solution. So I don't know why this is actually a separate outcome. It sounds very much like P7.3. So that is why they are together. Alrighty. So here we have some equations. These are not expressions because they have equal signs, so that's good. And you need to demonstrate preservation of equality. So 2x plus 5 equals 27. Your whole mission in life is to get the x naked and alone, with nothing stuck to it and nothing being added or subtracted to it. So the first step is to get rid of whatever is being added and subtracted. It's kind of backwards to BEDMAS, isn't it? We get rid of these extra chunks first. So what's the opposite of a plus 5? Well, it's a negative 5. So on this side of my scale, I'm going to be subtracting 5. So in order to keep my scale balanced, I need to do exactly the same thing on this side. Okay? So my plus 5 and my negative 5 cancel each other out, and all I have left on this side of my scale is 2x. I'm going to drop down my equal sign and keep it nice and lined up, and then I'm going to think about what 27 take away 5 is. Everybody agree? Okay, so my x is still not naked and alone. It's got this 2 stuck to it. So that means it's being multiplied by 2. There's 2 x's, right? 2x is 22. So I'm going to draw a fraction bar and divide, because that's the opposite of multiplying. And you have to think, what do I wish I had on the bottom so that I could get rid of that 2? I wish I had a 2. And that way, 2 over 2 cancels out. It's just 1, right? But if I'm going to draw a bar like this and put a 2 on the bottom, I need to do exactly the same thing on this side of my equation to keep everybody happy. What you do to one side, you must do to the other. So if I've drawn a bar on this side with a 2 underneath, I better be drawing a bar on this side with a 2 underneath. And I'm left with plain old x on this side, my equal sign, and 22 divided by 2, which is 11. And we have solved our equation. Okay, let's try this next one. 4x divided by 2, take away 1, equals 7. So the first thing I want to do is get rid of this extra chunk. That's the easiest way to start. So the opposite of minus 1 is plus 1. If I do that to one side, I better do it to the other. So these guys cancel out, and I'm left with 4x over 2 equals 7 plus 1 is 8. Right on. Now, I've got this fraction thing going on over here. What do I wish I had on the top so that I could get rid of that 2? I wish I had a 2. Okay. So now I'm left with 4x equals. Now, think about what I just did here, and I need to do it on this side as well. So if I've multiplied by 2 on the left side, I better be multiplying by 2 on the right side. Okay, so my 2's canceled out on the left, and if I multiply by 2 on the right, I get 16. 4x is equal to 16. Gee, I wish I had a 4 on the bottom so that my 4 could cancel out. What I do to one side, got to do to the other. X is equal to 16 over 4. And if you know anything about fractions, hopefully we do, we know that 4 goes into 16 exactly 4 times, so x is 4. All right, here are just a few more little examples. 1/3 of y take away 6 is 24. This is exactly the same format as what we just did. Start with your minus 6. What's the opposite of minus 6? Plus 6. So those guys are gone. If I'm going to add 6 on one side, I better do it to the other side as well. So 1/3 y equals 30. Okay, next step. I wish I had a 3 up top so that I could cancel everybody out. And if I'm going to put a 3 up top, that means I am multiplying. So I need to do exactly the same thing to this side. We're going to multiply by 3. So I'm left with, now technically I have 1y, but it's 1y is just y, right? So my y is equal to 30 times 3, which is 90. Good work. Okay, let's look at number 2. Start with your plus 12. Let's get that away from the a to start with. So we're going to minus 12 on this side and minus 12 on this side. 3 over 4a equals 42 take away 12, which is 30. Now, sure wish I had a 4 up here so that I could cancel out my 4's. What I do to one side, I better do to the other. 3a is 120. Now my a is still not naked and alone. Sure wish I had a 3 on the bottom so that I could get rid of it. What I do to one side, I do to the other. A equals 120 divided by 3, 40. Last example, 7n take away 3 is 25. The first thing I want to do is add 3. Those guys are gone. What I do to one side, gots to do to the other. 7n equals 28. 25 plus 3 is 28. Now my poor n, sure wish I had a 7 on the bottom. Okay, those can cancel out. If I'm going to divide by 7 on that side, I need to divide by 7 on the right. N is finally naked and alone, and 28 divided by 7. Done deal. Okay, so one of the outcomes said that you need to know what all these little parts are called. So here is the diagram that shows you that. We know what the variable is, right? The letter. And this is why we don't use our multiplication sign anymore. We're going to use brackets when we do work in these kinds of equations, because we don't want to use it as one of our operators, because people will think that we're trying to multiply. And we don't use that as a multiplication symbol anymore. It's a goner. We're going to use brackets instead. And you will also notice on Ames web tests that they use a dot sometimes to say 4 times 5. They just use a dot in the middle. So that means multiply, just so you know. Little tidbit there. Okay, so we know what the variable is. That's the letter. The constants are the numbers that are separate and just sort of constantly floating around here. They're all good. And the coefficient is the guy who is stuck to the x, getting multiplied by the x. It could also be being divided by the x. So if it was x over 4, we would say the coefficient is 4. So multiplying or divided. This isn't super important. You're not going to see this a whole lot this year, but they might talk about, they would more so talk about the variable, not so much about the constants. And you might hear the word coefficient. So, all right. My little joke on the side here, I don't mind doing geometry or algebra, but graphing is where I draw the line. Ha ha ha. So that is the whole purpose, like I said, of doing these two outcomes is that you're going to take this fancy equation, something like this, and draw what that actually represents on a Cartesian plane. So in this case, they did the math, they figured out that x equals 3. And so this is your x-axis, the horizontal one. The y-axis is the one that goes up and down. And so you always plot your points with your x-axis first. And so if they've decided that x equals 3, so they started at the origin, they went 1, 2, 3, okay? That means that anywhere on this line would satisfy this equation. So x is always going to be 3 no matter what the y value is. Okay, I'll just give you another quick example here. If our equation was 2x plus 1 equals y, I could plug any old value in for x. Let's say, what would happen if I put in a 0? Well, 2 times 0 is 0, plus 1 is 1. So in this case, if x is, I'll just make a quick chart over here, my x and y values. If I choose 0 for x, that means y is going to end up being 1. What about if I plugged in a 1 for x? Well, 2 times 1 is 2, plus 1 is 3. So if x is 1, y would end up being 3. We'll do one more. If I use 2 for x, 2 times 2 is 4, plus 1 is 5. So if x is going to be 2, that would make y equal to 5. So then this chart that I've got going on over here, these are my ordered pairs, 0, 1. So I could chart that on this graph that we have over here. 0 is my x value, so I'm not going to jump at all on the x-axis. I'm not going any direction left or right because it says I'm supposed to stay at 0. And then it says I'm supposed to go up 1 on the y-axis. There we go. So our first plotted point, I should actually get rid of this guy, pretend he's not there. Our first plotted point is right here at 0, 1. And then our next one, 1, 3. So we're going to jump 1 time on the x-axis, 1. And then we're going to go up 3. 1, 2, 3. Okay. So our next point is right here. And just for fun, we'll do this last plotted point, and it says 2, 5. So we're going 2 on the x-axis, and 1, 2, 3, 4, 5 on the y. Do you notice anything suspicious about my red dots? They make a line, and that's why these are called linear equations. Okay, so we'll see how good my drawing is here. Oh yeah, look at that, straight as an arrow. All right, good luck with linear equations.